Popper actually claims that induction plays no role in science at all. And so he can happily accept Hume's argument and go on about his merry way. As we saw back in Lecture 2, Popper thought confirmation is cheap. It's interpretation of data in the light of your theory. What matters to Popper is not getting evidence for your scientific theories. It matters whether your theories are subject to falsification. This is the key to Popper escaping from Hume's clutches. Popper thinks that scientific theories can be falsified using only observation and deduction. You don't need inductive logic at all. One black swan conclusively falsifies all swans are white. Notice that we're putting aside all the worries about auxiliary hypotheses we discussed a little while ago when we were talking about Quine. In principle, one can always modify the web of belief so as to preserve any hypothesis. For instance, the hypothesis that all swans are white. Popper's point is some ways of modifying the web of belief are unscientific. So we're going to put aside worries about holism for now. There's another worry about Popper that we can note and set aside, which is we saw earlier in the course that hypotheses of the form there is at least one X in the universe, like there is at least one unicorn somewhere in the universe, is not falsifiable by any finite amount of observation. It could just be around the next bend no matter how long you look. Popper denies that science has need for hypotheses like that. He thinks science has need for hypotheses of the form all X's are Y's, all copper conducts electricity. And those are fairly readily falsifiable. So Popper doesn't need induction. On Popper's view, scientists shouldn't try to confirm their theories. They shouldn't perform inductive inferences in the first place. The most we can ever say in favor of a theory or hypothesis is that it has survived our attempts to falsify it. And Popper calls this corroboration to distinguish it from confirmation. Now he's serious about distinguishing it from confirmation. The fact that a hypothesis has survived severe testing does not indicate that it's likely to be true, or that it's more likely to be true than it was before it was tested. So when Eddington failed to falsify Einstein's hypothesis that the sun would bend light rays that passed near it, that was not, on Popper's view, evidence that general relativity is correct. That would be an inductive argument. Popper has no use for induction. Corroboration does not indicate that a theory is healthy, just that it's not dead yet. The Eddington experiment tried to kill Einstein's theory and failed, and that's all we learn from the Eddington experiment. So Popper goes out of his way explicitly to deny that a theory's corroboration is any predictor of its future success. And he's got to deny it, because otherwise he'd be relying on induction. He'd be saying that past survival of strenuous tests is evidence for future survival. And that's an inductive argument. So you've probably seen commercials where stockbrokers are forced by the government to point out that past performance of some mutual fund is no guarantee of future performance. Popper's going beyond that. Past performance for Popper is no evidence at all of future performance. And he's got to stick to that claim, otherwise he's reasoning inductively. Now, at some point, we stop testing our theories. We start taking them for granted. And this looks like a problem for Popper, because it looks like we're deciding the theory has been supported by enough evidence that we no longer need to test it and we can start using it to design experiments to test other theories. Popper's response is we are saying no such thing. It's a decision about how to best use our time and our money and our lab equipment. It's not to say general relativity has been shown to be true. It's to say, all right, we feel like testing something else now, and we're going to use general relativity to test that. Similarly, outside of science, we can rely on hypotheses for various practical purposes, as we do when we get on airplanes. We're relying on Bernoulli's principle about lift. But if we're Popperians, this is not a judgment that the hypothesis is likely to be true. It's a decision about what to do, how to get from point A to point B. Now, Popper has some serious trouble explaining why it is rational to prefer corroborated theories to untested theories. He's got a point if he says that it's rational to prefer corroborated theories, theories that have survived severe tests, to theories that have actually been falsified. If we know that a theory is false, that's a pretty good reason not to rely on it. But remember, Popper insists that corroboration says nothing at all about the likely truth or future performance of a theory. And so the challenge for Popper is, why aren't all theories that aren't already known to be false on an equal footing. What's special about theories that have survived severe tests? Why should they be preferred to theories that have their names drawn out of a hat, or theories that can be formulated in the fewest number of words? Popper seems to say that the practice of science simply includes preferring corroborated theories. This is part of what makes science science, just as falsifiability is supposed to be part of what makes science science. It's how the game is played. But that's not an obviously fair move. The original demarcation criterion, the falsifiability criterion, was put forward to account for the difference between what Freud was up to, for instance, and what Einstein was up to. It was motivated by a desire to sort cases. And it's not clear what the motivation for the idea that scientists are just supposed to prefer corroborated theories to untested theories is supposed to be. It doesn't have a similar function in Popper's view. When Popper explains his position, what he tends to say is scientists should prefer corroborated theories because there's nothing better to go on. Since he accepts Hume's argument that induction doesn't work, there's nothing better to go on than theories that have survived severe tests. So far, so good. There is nothing better to go on if induction doesn't work. But there are lots of things that are no worse to go on. Choosing theories by reading tea leaves would seem to be no worse to go on. If severe testing is no guide to future performance, well, I think reading tea leaves is no guide to future performance of theories. And reading tea leaves might be cheaper, easier, more fun than choosing theories on the basis of which ones have survived severe tests. So it's misleading for Popper to claim that simply because there's nothing better to go on, we should prefer theories that have survived severe tests. We need some reason to think that it's a virtue of a theory if it has survived a severe test. And without relying on induction, he's going to have a hard time doing that. So both within science and outside of science. So within science, we use theories to design experiments to make predictions. Outside science, we use theories when we get on airplanes and decide how to spend our time. It's hard to see how Popper has given us a reason for preferring corroborated theories to untested theories. The best response I can make on his behalf is a kind of dance with who brung you to the bash principle. The idea here is you don't drop a theory until it fails a test. You've been using a theory, what you need is a reason to give it up. And until your theory fails a test, you've got no reason to give it up. But this relies, Dance with Who Brung You to the Bash is an old Western swing song, and it's a little more romantic than our choosing of scientific theories. You owe your date a little bit of loyalty. You don't drop your date if you see somebody you think looks better at the bash. Not clear that we owe our scientific theories that kind of loyalty. If there's no reason to think that a theory that has survived severe tests is going to work better than the next theory that pops up, why can't I switch just for the fun of it? So it looks like Popper either has to assume some kind of induction in order to get us to prefer corroborated theories to uncorroborated theories, or he's got to admit that there is no good reason for preferring either for scientific or for practical purposes theories that have survived severe tests. And ask yourself how much sense it makes to get on an airplane if you don't think past performance is any indicator at all of future performance. So we're in trouble if we can't defend the use of the past as a guide to the future. Both in science and outside science, it looks like we need to make inductive arguments, which means we need to have an answer to Hume. Now, one striking thing about Popper is he nevertheless thinks scientific theories aim at the truth, even though they can never get any evidence at all that they're getting there. So I'll use an example due to Peter Godfrey Smith, a philosopher at Stanford. Popper's conception of science is like you go around looking for the Holy Grail, but you can never get evidence that any grail you've got is holy. Right? There are a gazillion grails out there. And you want to carry one around and you'll drop it if you get some indication that it's unholy. Sometimes you can find out that a grail is unholy. But you can never, ever, no matter what happens, get any indication that you've got the Holy Grail. So you're seeking it, but you can never get the slightest bit of evidence that you found it, no matter what happens. It's nevertheless the goal of science to try to get true theories, but there is no way to get any evidence at all that you're getting closer to your goal. That's kind of a striking and peculiar feature of Popper's view of science.